Welcome to this short video covering the answers to the Unit 1 Breakout Session 1 quiz. So we're going to go through this real quick. All right, let's look at 1 through 5. The first question is, in the Marble Lab, the distance an object covers in a given amount of time is otherwise known as blank. So the key word here is distance. Distance is a scalar. Since it's a scalar, this must be referring to speed. Now, if we had changed that to displacement an object covers in a given amount of time, it would have been velocity. But number 1 is speed. All right, number 2 is a graph about the Marble Lab. And it shows 4 different slopes. And if you remember in our lab, it was a linear slope because the marble, as it came off of the ruler onto the table, the velocity didn't change, ignoring resistance. Ignoring friction. So some of you were considering when we were doing this lab to collect data, collect the time that the marble was rolling down the ramp. But we actually didn't want that. The ramp was just an inclined plane to change potential energy into kinetic. So it was just the velocity along the tabletop, and that was linear. It was constant. So that's going to be graph 1. All right, next, moving on to number 3. Blank blank is the speed at any given instant in time. We talked about this in class. Any instant is going to be instantaneous. And in your book, there was a section that talked about average velocity and instantaneous velocity, as well as instantaneous speed. So this is going to be any point on the graph. So we have a linear graph. We're looking for the speed at any given instant. That's any point on the line. Number 4, on a graph, the blank is the ratio of the vertical change to the horizontal change. So again, the vertical change, which is the rise, to the horizontal, which is the run. So you know rise over run to be slope. And number 5, based on the definition of slope, what did the slope of your Marble Lab graph represent? And you can see there's a little overlap in concepts here. We know that if we derived an equation using rise over run, and we also used the slope-intercept formula. And when we did those, we found that distance over time, or displacement over time, depending on if we're looking at distance, speed, or velocity. So the answer here is distance over time in terms of speed. So a distance time graph, we're looking at distance over time, rise over run.
Moving on to problem number 6. A car is driven 40 kilometers due west and then 30 kilometers due south. What is the magnitude of its displacement from the origin? For this, I'm going to say that to the left is west and the direction down is south. So we drive 40 kilometers to the left, west, and then 30 kilometers south, and it's asking for the magnitude of this displacement right here. I could write this in vector form as minus 40, comma, minus 30. This is the component form for the vector, telling me the 2 components. But the problem isn't asking for this form right here. It's asking for what is the length of this hypotenuse here of this right triangle. So to find this length, I will need to be doing the Pythagorean theorem. Let's do 40 squared plus 30 squared and take the square root of all of that. 40 squared is 160. 30 squared is 90. Take the square root of all of that. The sum of these two will be square root of 250, which is the same. The square root of 250 is 50. And because our units, we want to be consistent with our units are kilometers. The answer here is 50 kilometers. Moving on to problem number 7. Vector A is -3, 8. Vector B is 1, 2. When adding these 2 vectors together, what is the resultant vector r equals a plus b? To find the sum of any 2 vectors, you simply have to add their components. So our vector r is going to be, the x component will be -3 plus 1. The y component is going to be 8 plus 2. So the solution here will be minus 2 for our resultant in the x direction and 10 for our resultant in the y direction. Correct answer is A. Problem number 8. Chandra wants to run a 5-kilometer training run. Which of the following routes will give her a total 5-kilometer running distance? If she ran east for 8 kilometers and then west for 3 kilometers, she would have a 5-kilometer displacement, but she would have a total running distance of 11 kilometers. If she ran straight east for 2.5 and then straight west for 2.5, her displacement would be 0, but her total distance would be 5 kilometers. So we're thinking that could be the right answer. If she ran west for 10 and then east for 5, her displacement would be negative 5 kilometers, but her total distance would be 15 kilometers. And if she ran west for 5 and then straight east for 5, again, her displacement would be 0 and her distance would be 10. The correct answer here for 8 is B. Moving on to problem number 9. Which of the following is a vector? Your velocity, your age, your height, a distance traveled, or a point in time. The key thing to remember when you're looking for a vector or a scalar is, does the quantity have direction? Does direction matter when you are telling somebody about this quantity? So if you tell somebody your age, then you're not telling them you're 18, 15, 13, 14 years old to the left, to the right, or anywhere like that. Your height is simply a length. It's not going to have a direction. A distance traveled, again, can be in any direction. And a point in time, time is a scalar quantity. It doesn't have a direction, even a positive or negative, so time is not a vector. Velocity absolutely is a vector. The distance matters when we are looking at velocity. Problem number 10. A scalar quantity has only magnitude or direction, an x-coordinate or a y-coordinate. A scalar will be defined only by magnitude. The direction does not matter when talking about a scalar quantity.
For question number 11, what are the two concepts of the engineering design process that we have started for Unit 1? The answer should be D, SOP, or Statement of Purpose and Research. Refer to your notes that you took from Miss Harmony's breakout session number 1 if you are questioning this answer. Number 12, what three questions need to be answered for your SOP or your Statement of Purpose? The answer to number 12 should be B. Always answer who, what, and why. Who are you making the device for, or who is your user or customer? What do they need the device for? What do they need the device to do? And why do they need that device or that prototype? Number 13, which of the following are branches of physics? The answer should be D, all of the above. So optics, kinematics, and thermodynamics are all branches of physics. Refer to the YouTube video on the introduction of physics for this information. Number 14, the essence of engineering is B, design. Refer to the Intro to Engineering video on YouTube, on the YouTube link for this. And number 15, which is not one of the 5 R's in Cornell note-taking. The answer should be E, repeat. And also again, refer to the YouTube video that you were supposed to watch on Cornell note-taking for information on this.